One question came up in the break, and a person asked me, what is the difference between a catchment, a basin, and a watershed? And there's not a real difference. These are different words for the same thing. A catchment is the same as a watershed. The word basin is also the same. However, basin is usually used for larger catchments. Like you say, the Nile basin. Yeah, you can say the Nile catchment, but that's a bit less common. But it's just a different word. You can also, a small catchment, you can also call that's my basin. Yeah, you can also say that. But you wouldn't say that for the whole Nile or the whole Mekong or the Mississippi. Then you talk more about the basin. That's the only difference. They're all the same thing. Good. I would like to speak now a little bit about some influences of man. This is a topic that will keep you busy for the next years. So it's not that I'll just give an introduction to it. Well, if you have this catchment, by the way, we were not able to get this blackboard down again. But the good thing is you always see the water balance equation. Yeah, so that's the most important. No, but I'm sorry for this. We have to get a mechanic to repair that. If you have a catchment like this, you see the watersheds divide, rainfall, evaporation, and discharge are leaving. Then you can do the water balance for the whole catchment, yeah, for the whole Nile or for whatever. However, note that that's for the whole catchment, but there are several smaller catchments embedded in the big one. For instance, an urban catchment here in the city, or above this reservoir, or here in this forest. You have in the forest very often you have also recycling of water, so you have evaporation, cloud formation, and rainfall again in the same area. So you have water going in cycles that can happen within a catchment. Yeah, like in the Congo basin or the Amazon basin, you have a lot of evaporation from the Amazon itself, evaporating, forming clouds, rainfall again. So you have a cycle within the basin. Yeah, so you have embedded in the overall basin smaller basins or catchments everywhere. Yeah, you have to realize that you have to realize for which entity, for which size you do the water balance equation. Yeah, and there are smaller water cycles and catchments embedded in the big thing. Is that clear to everybody? Good. Now we have several changes in a catchment. Of course, we have human activities, as you see in this figure. We have maybe a reservoir. I hope you can see this. Here, a reservoir and return flows, irrigation demands, and whatever going on. Other thing which always comes up if we talk about global changes is the global warming. I'm sure everybody heard of you about global warming. My mother nowadays talks about global warming, and she's not a hydrologist. Yeah? And why are you laughing about my mother? You know, she could be a very good hydrologist, I think. Now, everybody talks about that. I think the Nobel Peace Prize from Al Gore and the IPCC report helped a great deal of increasing that awareness to climate change and global warming in particular. And it's true, it's getting warmer. Yeah, we don't know how much warmer it actually gets, and I could speak hours on this, but I keep that for other lectures. But it for sure gets warmer. Also, we can measure that. These are measurements from the last 150 or so years, and you see there's a very significant temperature increase, in particular in the last decades. Yeah, there were other temperature changes, and I don't want to go into all that discussion, but it is getting warmer. For us hydrologists, the most interesting is what does that mean for the water balance dynamics? What does that mean for the rainfall? What does that mean for evaporation? And what does that mean then for the runoff dynamics? Yeah, and they are likely to change as well. Yeah, so there are a lot of changes happening at this moment. Like I tried to summarize that, like. Climate change we have, that's the change in temperature, that's for sure. But maybe more interesting is the change in the rainfall, change in radiation. What does that mean for evaporation? Huh? That's more interesting. Land use change, we have a lot of deforestation, reforestation. You see here this pattern. Yeah? Urbanization, this is a picture from Bolivia, La Paz, and there's a lot of urbanization going on there. You can see this. Huh? Deforestation, you see here, irrigation, water resources development, etc. Population amount. It's not so much that we in 2050 likely have 9.2 billion people on this planet. We have some 7 billion at this moment, but this additional 2.2 is a lot. But it's not so much that we have the total number, it's more the concentration of people. So they all live in the wrong places. Not all, but many. So in coastal areas and urban areas, they are growing very rapidly. Urbanization is a big issue. Then people get older. When you get older, you need more water. You have a different population structure also. Water use, economic development, change of the diet, more meat, more water. Is that clear to everybody what I mean there? If you eat more meat, you consume much more water. I think you had that in the first week very clearly. Huh? Changes of the nutrient fluxes. P is here phosphorus, N is nitrogen to the water bodies. Population, etc., etc. So many things are changing at the same time. Yeah? The number of McDonald's restaurants is changing all the time. Which is also true. And that also expresses a different consumption pattern. Yeah? That if we change our diets. And there are several feedback mechanisms between that. Now I want you to look at this from a hydrological point of view. If you change the land use, for instance, we have this. I think we discussed this quite in detail this afternoon. Oops, is there not a? Oh, no. We have the first incoming rainfall. Either it's interception or not. And if you have forest or non-forest, it makes a big difference in interception. Huh? You agree that? Yeah? That's the first diversion point. The second is maybe here at the leaf. Then is it then transpiration at the leaf, or is it not transpiring water? That depends with the root water uptake and the radiation and water demand, etc. Then we have a decision here. Is it infiltrating into the soil or overland flow directly, runoff generation, or is it soil evaporation, staying here at the soil surface, whatever? Or is it then from infiltration water going down to the groundwater, or is it taking up by roots into the vegetation, etc.? There are several different mechanisms also here. So you see that the vegetation is changing our water balance equation quite significantly. Almost all the parameters that we wrote down here are depending on vegetation. Yeah? So whatever vegetation you have, the total water balance is changed. The challenge now for hydrologists is to put numbers. Well, with errors, you believe me, yeah? But now to say, if I cut that forest, then the different evaporation terms are changing so much. Exactly, that's very difficult. And that needs a lot of process understanding and detailed measurements and detailed modeling. That's what we do in hydrology. Yeah? But globally, you agree that it's all changing. Yeah? And the same is true for land use, for climate. If you have more energy in the system through higher temperatures, all these parameters change again. Yeah? And that makes it so difficult for us to predict the future, to predict the impact of climate change, to predict the impact of land use changes. Because they're all changing at the same time. If only ET would change, because of a changed vegetation, it would be easy. Huh? Then we could solve that equation quickly. But all parameters change. And that makes it so difficult. I just as an example, I want to go to one figure. This is a landscape from India, southwest of India. Yeah, semi-arid landscape. What they did there, they were planting jatropha. Jatropha is a plant that is used for biofuel production a lot. Yeah, it's also heavily advertised to use jatropha for biofuel production. Yeah, don't want to say more about biofuels. It's one of my research fields, but it's quite interesting what is happening there at the moment. It's the same area, but this is 3 years later. Yeah. So now put on your hydrological glasses for a moment and think about what does it mean if you change the land use in this area. You probably all agree that the interception evaporation is much larger here than there, because more canopy, more water stored there, more water evaporates back. Clear. Therefore I made the width of the arrow a bit wider. Huh? The soil evaporation, the transpiration is maybe also much larger here than there. You agree? Yes, because you have more vegetation taking up water, transpiration. The soil evaporation is maybe the other way around. Maybe you have more soil evaporation here than there. You agree? You see that evaporation is not going up or down. All the different evaporation fluxes are changing. And that's what we need to account for. So it's more complicated than just solving an equation a bit differently. Yeah? The soil storage maybe is much larger here, because here you have more roots in the soil and more fine roots, and they put the aggregates of the soil a bit differently, and so you have maybe larger soil storage and therefore larger changes also than maybe here when you have sandy soil conditions. But it could also be the other way around depending on the soil physical parameters. The recharge is maybe larger here than there, Because if this is sandy, then maybe most of the water is infiltrating and then percolating down to the groundwater. So you have more groundwater recharge. If you have more groundwater recharge, then we also have more groundwater discharge. Yeah? So for downstream people living somewhere downstream who depend on the groundwater from upstream, it has a big difference if they're plant jatropha or not. Yeah? So being more green here is not necessarily much better for the environment and for the people, if you look at the water balance equation. The overland flow maybe is larger here if you have a lot of heavy machines going up and down, working on that soil, compacting the topsoil. You have less infiltration and more overland flow here than there. But if the soil physics conditions are completely different with more clay soil here, maybe it's the other way around. It depends. I just want to make the point it's different to the vegetation. Maybe the overall flow is larger here than there. The overall flow out of this landscape, yeah, than here. Because here more water is used by the vegetation and not producing discharge. Less runoff generation. You get the point? If we now have more evaporation in total here than there, then there's more cloud formation. More clouds can also rain more water. So it could be more recycling of water, so more precipitation. So if you evaporate more water, then also more rainfall will fall down again. Like in the Amazon. In the morning you have central Amazon, you have a lot of evaporation in the morning, and then in the early afternoon you have a rain shower. And that's the evaporation from the morning to a large extent. It's evaporating, cloud formation, we come to that later, how that works, and then it's falling down again. And if you have more forest, then you have more circulation, yeah, more feedback of that moisture, while if you would cut all that forest. Yeah. But to change the precipitation pattern, you really need to do it big scale. You would really need to change the land use at very big scale. So it's not enough just to cut a couple of, a few hectares. So you really would need to cut half of the forest. Yeah? Is that clear to you? Now something other. You have a question? Yeah. Yeah. This is the recharge. I called QR recharge for a moment. It's maybe if you have sandy soils, you have more water going here in the recharge percolating down to the groundwater. Here, maybe compacted topsoil, less water infiltrates, and then less water can percolate, so less groundwater recharge. But depending on what kind of soil physical conditions you have, it could also be the other way around. I don't know, but
runoff there could be much more.
Yeah, but then it's subsurface runoff, huh? It percolates down to the subsurface. But it really depends on the soil physical conditions. You could be right, I don't know. My point is that the land use changes it. That's my point. Yeah? How exactly? I just want to illustrate the problem. Yeah? So we changed the rainfall, we said. And interesting is now, maybe you're all familiar with the geography of the Nile. Huh? Many students here come from the Nile countries, I suppose. Huh? The Nile in Egypt, when it discharges to the Mediterranean Sea, more than 80% of the water in that arriving in Egypt, even before it goes to the irrigation in Egypt, comes from the Ethiopian highlands. Yeah? Most of the rainfall in the Nile basin falling to the Ethiopian highlands. Then there's a runoff generation, and it goes to the Abai, to the Blue Nile, and then it goes to the Tall Nile. So whatever the Ethiopians do to the Nile and to the land use, because the land use influences the runoff, is very sensitive. It's very sensitive for Sudan, sensitive for Egypt, and for peace in the whole region, because it's an extremely watertight situation what we have there. So the Ethiopians, they have a lot of power, you could argue, because whatever they do to their hills defines how much runoff the Egyptians have. And the Egyptians, of course, observe that very carefully. They have a close look at what they are doing. You can be sure of that. And now, there's an agreement, I don't want to go into detail, was signed in 59 or 54, sorry. 959, okay, good. I'm not 100%. You know better. I believe you. Doesn't matter. Was signed, and the water resources were divided. But the Ethiopians say, maybe that's not so fair the way it was done at the time. So I don't want to enter that discussion. We don't want to have fight here. No? But it was distributed. Now, if they develop,
It's because it doesn't belong to us.
Doesn't belong to you.
100 colonies. That's why the British and
yeah, I think you're right, but I don't want to enter that. I think you're right, but I'm not the person to judge that. I'm just we forget about water management and peace and whatever for a moment. Yeah, it's the most important, of course, but we only look with our hydrological eyes. So what the Ethiopians are doing to the water is very sensitive for the whole region, which is really a sensitive issue. At the moment with the development of the dams also, at least one is already in construction, that's very sensitive. Now, we said we can change the precipitation. Now you think, where does the rainfall in Ethiopia actually come from? Yeah? Partly it comes from the Indian Ocean. Yeah, most of it actually. So in the Indian Ocean we cannot really control the human, so that's kind of belong not to us. But it also comes from the White Nile and the Congo basin. There's some moisture flux from the west, bringing water that is evaporation in the Congo or Uganda area or southern Sudan, evaporating. The wind blows it to the Ethiopian highlands and rainfall there. So it's not only what the Ethiopians do to the land use defines the water resources in Ethiopia and therefore the whole Nile. It's also what the Congo is doing. So if you would cut all the forests in the Congo, which of course will never happen unfortunately, but if you would cut significant parts of the forest in the Congo, that would change the moisture feedback back to the atmosphere and therefore change the rainfall conditions in Ethiopia and therefore the runoff in Egypt and therefore peace in the region. Honestly, I believe that. You see, the Congo has, whatever the Congo is doing, the Egyptians should also watch very carefully, or what Uganda is doing, or South Sudan. Yeah? Because some of the moisture flux come from that region. Yeah? I can show you papers and substantiating my story here. But you see how everything is connected. So you're not changing also the rainfall in your own basin. Maybe you change also the rainfall somewhere else. Yeah? The same is for we have probably some students from China. Yeah? Do we? All these rivers in China, the big rivers where more than 1 billion of people depend on. That's a lot, huh? More than 1 billion of people. They all flow from the east to the west. From the west to the east. Yeah? The Yellow River, the Yangtze River, the Mekong goes into the south, and etc. And now you ask, where is that moisture coming from? It's partly coming from the Chinese Sea, Pacific Ocean, yeah? But it's also coming from Asia and Europe. It's the western wind drift that redistribute moisture evaporating in Europe, Russia, former independent, now independent states, former Russian states. Whatever happens there makes the rainfall in China. So the Chinese are not only having their own water resources under control, it's only their territory, so they don't need to fight with somebody, but they should also watch very carefully what the European and the other Asians are doing to the land use, because that's changing the feedback back to the atmosphere. You see how everything is connected. Yeah? You get the point? So if you are becoming the water minister of Egypt, do not only watch your friend from Ethiopia very carefully what he's doing. No, you also watch the whole African continent, please, and see how sustainable they work with their land use, because it all has hydrological feedback. That's my main point. Do you get that? Good. Why do you understand that so quickly? I needed years to understand that. It seems you're much smarter than I am, but that's not the point. But I want you that you think in a connected way, that you realize how water resources, all these fluxes, what I explained most of the day this afternoon, how they all are connected. That's what you have to realize. Yeah? And putting numbers behind these errors is the big challenge in hydrology. Yes, please.
Why here in Netherlands it's raining so much?
Well, I'm not sure it's raining too much. It's raining a lot. It's 800 millimeters per year on average. Where are you from, if I may ask?
Rwanda.
Rwanda. There you have even more rainfall in most of Rwanda. Well, not in the mountains in the western part. You have even up to 1500 millimeters, so partly twice as much as in Holland. In the eastern part towards Tanzania, you have 800 and less millimeters. Huh? So it's not too much. But how the rainfall is generated will come later today on a Friday morning. I come to that. Other questions? Is that clear to you how everything is connected? Good. Then we learned something today. But all short-term and long-term dynamics, they all are connected to the land use. Yeah? And not only in your catchment, also in a global way, and we need to understand that much better. Much more research is needed to understand that better. Hopefully you contribute to that with your master and maybe PhD research later. My water balance equation, and the point is that here all these parameters change depending on land use and climate. I really apologize for this stupid blackboard that we cannot see this. If that is clear, we just look at a couple of examples. Always good to show some examples. This is a water balance equation for two areas where you compare forest and open land. Open land means grassland and agricultural land. Both have precipitation 100%. The evaporation from the forested catchment is 52%. From the open catchment is 42%. So much more evaporation in forest. Therefore, the runoff is then the other thing, 48% or 58%. Clear. More forest, more evaporation in this catchment. If we now look at the different fluxes of the evaporation, you see the following. In the forest, most of the evaporation is actually transpiration. Yeah. Of course, then soil evaporation and interception evaporation, roughly the same in this forest catchment. While in the open catchment, most of the evaporation is soil evaporation. Yeah. While transpiration is much less, and interception evaporation is also much less because much less canopy storage. Yeah. So you see, you can break down the different evaporation fluxes, and you see how the land use is changing not only the total evaporation but also the evaporation fluxes. Is that clear why we have much more this type of evaporation in forests when compared to open land? Did I explain well? Somebody wants to repeat that? At this time of the day it's maybe wise to double check if you really understood. Why is there more in the open catchment and the open land? Why is there much more soil evaporation than transpiration?
Because there is no vegetation cover in the open.
Much less vegetation cover, maybe some grassland which has much lower canopy storage, much less roots, much less in total transpiration, therefore a complete different behavior. Thank you. Other things how we humans are changing is through reservoirs. What you see here is a very long discharge record from the Meuse. You see here the 1890 till 1900, so 10 years in the 19th century, and then the last 10 years of the 20th century. Yeah, here's a big break. You see here the annual discharge goes from between 1500 and 200 cubic meters per second down to 100 to 1500. The other one is more difficult to see, my apologies. That's the moving average minimum discharge. This goes from 4 to 8 up to 10 to 12. So the minimum discharge is much higher. The maximum discharge is much lower. How can that come? This is the maximum, this is the minimum discharge. Minimum discharge goes up, maximum discharge goes down. And do you have any idea how that could happen? More use of water, yeah, and it's regulated by dams. Yeah, what we did here in Europe, we built a lot of reservoirs, yeah, and that's damming increases the low flows and decreases the high flows because the high flows are stored then in the reservoirs. Yeah, so you see these nice changes. Other changes are more use in the water through more population, irrigated agriculture, etc. I skip this. Come to my last point. You will do an exercise with Dr. Laat on this. How do you get hydrological data? Just one slide on this. You will explore different sources of data through your studies here, and then also collect, download, organize data yourself in the taught part, and then in the thesis part you will maybe collect primary data yourself, where you measure discharge or rainfall or whatever. Generally you can find a lot of data in national and regional archives or in private organizations. Some of you work also for the public sector, in ministries or hydrological or environmental surveys, etc. Private sector organizations or dam authorities or management units, agricultural, irrigation agricultural schemes, they collect a lot of data where you can get a lot. Then you can collect secondary data from research papers or other project reports. surveys, some agencies, different types of archives. Sometimes if you want to study historic floods, maybe even newspapers can be useful. Of course, you have to digest the data published in newspapers very, very carefully. It could be completely overdone or so. But yeah, it's a source of information. Yeah? Own field observation, interviewing people, etc., etc. These are all different sources of data. We come to that in much more detail. I just want to make you aware of, if you want to tonight say, well, I heard so much about the water balance, now I want to really study my water balance in Trinidad or whatever, challenge Mr. Uhlenbrock if he had the right numbers, yeah? Then go to the, for this case I would maybe start with the ministries or the Department of Water Affairs or whatever that's called in Trinidad, I don't know, or in Ethiopia or wherever. Some are very open with their data politics and policies, and you can find a lot of data on the web, yeah. There's also one thing, in case you become the new Minister of Water Resources of your country, what I hope, yeah? And there are at the moment 4 acting ministers, alumni from IHE at this moment. They are acting at the moment Minister of Water Resources in their home country, 4 at the moment. So it's not so unlikely that you also get there at some stage. Not sure if you want to be the new minister, but I keep that. But if, yeah, or if you're at least kind of a decision maker when it comes to sharing of water data or hydrological data in general. Just my philosophy and what you hope understand, be always open. Put everything on the web and share everything, yeah. The downstream countries, if you have some trouble with them, they have the data anyway. Yeah, they know, they have their channels and whatever. Data is no secret anymore. Since we have internet, data is no secret anymore. So give up on this. Put everything for free on the web. There's many reasons why I sometimes criticize the North American politics. Yeah, but I don't want to go there today. But one thing is good. They say every data that is once collected by taxpayers' money, we put for free on the web. Yeah, so all discharge data from all rivers in North America, you can just download. Try tonight, go there. Yeah? For instance, the Global Runoff Data Center is collecting data from all around the world. You can send them an email, you get access to all discharge data. But some countries are really a bit difficult, yeah, to say the least. They don't share their data. They don't put it there for free. But that's absolutely wrong, because nothing you can hide anyway. Yeah, and if somebody, a downstream country wants to make trouble, they know the data anyway already. Or they have, nowadays we have satellites, we have global data models, we can run models and predict the data pretty accurately anyway. So they know. If they want to know, they want to know. So, but to make it freely available for researchers and on the web for everybody, that's a much better policy. Then a lot of research is done, and if you give people to play with, then you can use it. So if you are a decision maker in the future in your country, please, the first thing, make everything freely available on the web. Yeah? And don't be afraid of the neighboring country could kind of, see something they don't know. They know already. I'm quite sure. We have so many alumni in all the different countries. They know how to download data. They know how to run prediction models, etc. So the more you can always make more peace if you share everything you have. And don't worry about not getting more back. You always get more back if you share. So keep that, and keep that philosophy also for your own master research thesis and in the future, etc. But these are some sources of data which I wanted to briefly introduce today. Any addition to that? Any question? No. Any future water minister who doesn't like it any? Not now. Good. Let me conclude this lecture. I hope I was able to explain the hydrological cycle. I hope I was able to explain that it consists of many different components, different storages and fluxes. Don't confuse storages and fluxes anymore. Yeah? What is infiltration? Is that a flux or is that a storage of water? It's a flux. Yeah. And water stored in a reservoir, it's a storage, not a flux. But you still see this in MC reports, they use the wrong terminology. What is the unit for a flux? Volume per time step, change volume per time. For instance, millimeter per day, or discharge could be cubic meters per second, or whatever, volume per time step. For catchments, we give it in millimeters per day. And for a storage, what is the unit there? Cubic meters or millimeters. Yeah, volume. Exactly. And if you ds dt means volume change per time step. ds dt, don't forget about the dt. very important, yeah. And still so many people forget, yeah. And I don't expect that from you anymore. And if it happens, you get my red pen in your thesis. Yeah? Good. I explained that. Then we explained about the hydrological base unit. That's a catchment. I think that's clear for everybody. Talked about water balance equation, that we usually solve that for a catchment. The big challenge is, what is the catchment? We said that boundaries of a catchment can change in space and time due to varying water levels in the groundwater or in the river itself. If the river flows the one or the other direction, like the Orinoco, or some lowland rivers here in Holland. We discussed all fundamental processes. Of course, I went through it very quickly. This was a hydrology process lecture in very quickly, but I think we mentioned all key processes. Water balance equation. We discussed the rainbow of the water with the green and blue water. Blue water is the water resources, mainly in the river, but water managers realized that actually a lot of water resources are in the groundwater as well. Green water is the water uptake through vegetation and evaporation. We discussed hydrological regimes, and they are affected by climate change and other global changes. I personally believe that the land use changes are often much more drastic than climate change, and they impact hydrology and water resources much more drastically than climate change. But that's the own lecture series we don't do today. And it needs a lot of hydrology research to fully understand that. Yeah. Any questions on this part of the lecture? All crystal clear? Good. I needed days and weeks to understand this. Yes, please.
Just like to make more clarity about the basin concepts. If more rivers are 4 and 5 rivers are coming together and they are united or join in one river, so the basin can be drawn for all the 5 rivers, or it has to be individual basins for each river?
As you like. If your integration point where all rivers come together is downstream of that confluence of that 5 rivers, if you put that point downstream, then you have to include all rivers. But maybe they are very different. Maybe you have a flooding problem downstream, and then it's very wise to look at the 5 rivers separately and their catchment separately, because maybe one is forested, the other one is agricultural use, and one is more urban or whatever, and you need different approaches there. And then it's wise to look at these separately and develop solutions for your problem per sub-basin specifically. But they're all in one river basin, yeah? For the Nile, if you only look at these numbers for the Nile, we said the total Nile rainfall was 220 millimeters per year. This is true for the total Nile, but it doesn't tell you much about the real problems in the Nile. You need to understand the hydrology of Ethiopia if you really want to study problems in the Nile, because that's where most of the rainfall is falling. Then it's very wise to separate the Ethiopian subcatchments and other subcatchments, because you understand better. So it really depends on what question you have, on what problem you want to solve, etc. Yeah. Other questions? Yes, please.
Change in hydrological regimes in Congo affects the hydrological regime in Ethiopia?
To some extent. It's not defining it, but to some little extent it has an impact.
That's my question. About how much change the affects, like 30% of the change in the hydrological regime will affect Ethiopia, or more massive change will affect?
Yeah. I can't answer your question. It needs more research. However, to really change the rainfall pattern in Ethiopia, you would need to change the land use at very significant scale. So not a couple of hectares or a few kilometers square, that you won't feel in Ethiopia. So you would really do massive changes. But yeah, if you would change for the eastern Congo, Rwanda, and part of Uganda, or you change the land use there, that would have an effect. But that's also very, very massive. You know, you would need to cut forests at very large scale. But it's not that this is happening. I don't want to make somebody afraid. I just want to explain you how things are connected. Yeah? But I can't answer your question how many hectares would need to be cut. So I can't answer that. And it needs really complex global circulation models that compute that, and a better understanding also of the processes. Still needs a lot of research also. Other question. You have a similar problem with the Amazon for people from Latin America, the Rio de la Plata and the Amazon. There's a lot of discussion at the moment, if climate change continues, that the southern part of the Amazon becomes a savanna type of landscape. Yeah? And that would really change the moisture flux to the Rio de la Plata, which is a huge river then coming in by near Buenos Aires. Yeah? So the savanization of the Amazon, if that would really happen, and they talk about thresholds, if the temperature increases above 3 to 4 degrees, yeah, then really the whole ecosystem on the Amazon would change, some people say, and they predict that then you have a savanna type of landscape in the southern part of the Amazon, and that would change completely the moisture fluxes in the Amazon, but also in the Rio de la Plata. Yeah, the southern big river basin going to Paraguay, Argentina, Uruguay, then this part. Yeah. Another example of how things are connected. Yeah. Other questions? Yes, please.
I know the difference between the basin, the wet basin and the catchment.
It's the same thing. I'm not a native speaker, you know, but I kind of grew up in a society where we say more catchment, and you can say basin. It's the same thing. It's just a question of scale. The word basin usually is used for larger units, like the Nile basin, yeah, or the Amazon basin. But you could also say the Amazon catchment. Do you have a native speaker? Is that correct? Huh? As I explained it.
My first language is Spanish.
In Spanish, good.
But
You're excused for a moment.
in the U.S. they do use more watershed.
Watershed, yeah.
So it depends on where you are.
Yeah. And all is right. It's not wrong, but watershed is more a catchment usually used, or yeah.
And you can have like watershed, basins.
Yeah. Yeah. But the British hardly use the term watershed, I think. But yeah. But it's the same thing. That's the most important. Good. Other questions? Yes, please.
Is there any technical reports or similar documents in which that climate change variable is inserted into the water balance equation?
Oh yeah, lots. We do a lot of research here on this.
But like official documents?
Published papers, tons and tons. Yeah.
Because I'm seeing a lot.
Yeah, many. But maybe if you're specific in one region of the world, then I don't know. But there's so many publications on climate change impact on hydrology. There's hundreds per year, published papers.
Is it related to return period or?
Yeah. We do this work as well. So we also publish papers on this field. Yeah. Yeah. We do some work in the Yellow River, for instance, on climate change impact on temperature, rainfall patterns, discharge patterns. But also in other catchments of the world. Yeah. There's a lot of many masters students also work in that field. If that's something you're interested in, and you would like to do that in your home country, you're more than welcome to. We find it a good topic for you. Don't worry. Other questions? Yeah. And maybe it's wise. Last question. Yes.
You just make a point about that table. So if it is better if you can include the Indus Basin, because Indus Basin is a big catchment area. It's about 900,000 kilometers square. It's more than most of the rivers and so on in the river. If something is added about the Indus Basin, it is helpful.
No. You talk about this table. Yeah. Well, I copied that from the lecture of the Laat. I need to say it didn't make that table.
Actually, it's better to have a comparison about the Indus Basin, because just rising from the Tibet and going down to the southern Indian Ocean, so its catchment area is around 900,000 square kilometers. So it's nothing mentioned about it. I said,
Yeah.
From the net some details about it.
Thanks. There was no reason omitting any basin or so. I just copied the table from a lecture note. And when we found a mistake here with the Mekong, which looks a bit funny. But I don't have the numbers for the Indus. But I agree that it's a super important river basin, also transboundary with lots of issues connected to it. So I agree that this is very important. Yeah. But there's no reason for omitting it. Yeah. Good. Maybe to refresh you, and we have another 45 minutes to go, I suggest that we make 50 minutes break now. And we start again. Then the next topic is then precipitation. So we start with rainfall and snow and ice. Thank you.